Okay, so again, we want to kind of find this middle ground between these old methods supported by the new methods that we're talking about, right? This behavior of f. So as far as finding the domain, there's still nothing wrong with saying 2 minus x is equal to 0, which means that 2 is equal to x. That's the value that's excluded, right? That's that excluded language right here. So we would say something like our domain. This does ask for interval notations. That would be from negative infinity till 2 union to infinity. Again, if you want kind of math shorthand, all values that look like x in the set of real numbers excluding 2. But this is maybe our more formal answer. I'm okay if you write the other one on an exam though. Okay, so this is our excluded value. But this question also asks us to discuss that behavior, right? What's happening to our function around the value x is equal to 2? So we actually do the same exact thing we did in the previous video, but now we're going to do it around 2 instead of around 0, because 2 is our excluded number. So we would say something like, again, you have x and f of x, and you could write this vertically if you really want to. This is just the habits we have. So I want to approach 2. So x approaches 2. Often we start with the left. There's nothing particularly special about it. You could start on the right if you'd like. A lot of times we start about a number away, so like 1, right? So if we plugged 1 in, that would be 1 plus 7 over 2 minus 1. That would be 8 over 1, which is 8. Okay, if we plug in maybe halfway, so 1.5, and again, feel free to throw calculators in this, you end up get 1.5 plus 7 over 2 minus 1.5. So that's 8.5 divided by 0.5. And you get 17. Okay, I may need to scoot this down a bit. How about 1.9, right? That's getting much closer. Again, we kind of have these fairly consistent values we plug in. There's a little bit of room for flexibility, but I'd be looking for something close to this on a test. 1.9 plus 7 divided by 2 minus 1.9. So that's 8.9 divided by 0.1. And that gives us 89, much larger. And, I'd say maybe 4 or 5 values like we did in the previous one is a good idea. 1.99. So we get 8.99 divided by 0.01, which I'm sure you can guess. Maybe don't guess, maybe double check it on a calculator or do your division. Let me do one more just to be consistent with what we had in the previous example. So 1.999 plus 7 divided by 2 minus 1.999. So that's 8. We're at 8.999 divided by 0.001, 8,999. So what happens as x approaches 2 from the left? Well, I would argue that f of x, those values are increasing, and they're increasing pretty drastically, right? So we have f of x approaches infinity. And this is something we should be able to predict with if it really is a vertical, a 0, if it really is a value that's removed from our domain here, then I should be expecting infinity or negative infinity on the other end of this. So again, here we have x values approaching 2 from the right. What happens to f of x? And we'll plug in maybe 2.001. So 2.001 plus 7 divided by 2 minus 0.001, 2.001, excuse me. So that's 9.001 divided by negative 0.001, gives us negative 9,001. And then 2.01, 9.01 divided by negative 0.01 should give you negative 901. 2.1, so 2.1 plus 7 over 2 minus 2.1, that's 9.1 divided by negative 0.1, negative 91. I would then say 2.5, so 2.5 plus 7 over 2 minus 2.5, 9.5 divided by negative 0.5. Would give us negative 19. And maybe 3, again, just mirroring kind of the same values. 3 plus 7 divided by 2 minus 3 would be 10 over negative 1, which is a negative 10. So as x gets kind of further and further away from this value of 2, maybe that's the opposite direction I want to say it in. As values from the right to the left move closer to 2, so larger than 2 inward, f of x is getting more and more negative. So it's going negative in the negative direction, and that magnitude of that quantity is increasing. So this is negative infinity. So as far as behavior and a way that you could word this, so you have your domain written at the very top, but we also have, as x approaches 2 from the left, and feel free to use a shorthand with the negative symbol, that's fine, f of x increases without bounds. And you could maybe say towards negative infinity. And then similar to that, as x approaches 2 from the right, f of x decreases without bound towards just infinity. And you could put positive infinity. Sometimes we see that notation just to make a distinction. I will say that sometimes formatting does vary depending on textbook, author, sometimes even instructor, but there is often a base understanding of what we're talking about. So I would say language like increases without bound, I didn't highlight these, but decreases without bound is very common language, as is our arrow notation that we use here. I think that's what our textbook actually calls it, is arrow notation. That would be okay. I would even make a case. So for this first one, you could even say, as x goes to 2 from the left, f of x approaches negative, and I would be okay with that. Okay, so just some variety, just showing you some different examples. I'll let you try this on the next page, and then like I said, we'll tie this in with asymptotes.